Hello children. So now we are going to do sequences and we will try to find the general rule of a geometric sequence. I believe you know what geometric sequence is. Geometric sequence is when you have a common ratio and when you multiply a certain number to a term, you get the next term, right? Sometimes the geometric sequence will have a ratio which is less than 1. So what happens, the number of terms will go on reducing. But if the common ratio is more than 1, so the number of the next number will be obviously bigger than the previous number, right? It is called a converging. I'll explain you here. Look. Suppose if I have a sequence something like this. Okay. 2, 4, 8, or I'll take 3, 6, 12, 24. What do you see here? What's happening in this particular sequence? We see that 3 is multiplied by 2, we get 6. 6 multiplied by 2, we get 12. 12 multiplied by 24, 2, if we give, we get 24, correct? So basically if you see 6 divided by 3, you get 2. 12 divided by 6 is also 2. So any next term divided by previous term, you get certain integer which is, or certain number which is your common ratio. Here we say the common ratio is 2 and we denoted it with R. Clear? So common ratio you have understood, it is basically R. Now if R is less than 1, so here what you see, I was telling about converging series. Here see a small term is becoming bigger, bigger and bigger. So the series is something like small term, it's going on becoming bigger. So this kind of series we call as diverging series. Diverging series or sequences, right? On the other hand, if I reverse this whole sequence, 24, 12, 6, 3, 1.5, 0.75 and so on. You see here what is the common ratio? It's not 2, it's half because the number is becoming half. How do I find? Any term divided by its previous term. 12 divided by 24 is half. Any term. Take this one. 3 divided by 6 is also half, or 6 divided by 12 is also half. Now half means 0.5, it is less than 1. So whenever R, here R is how much? R in this sequence is half. Whenever R is less than 1, like in fractions like half, 1/3, 1/8, the next term will be obviously lesser than the previous term. Such kind of series, if you see it from a bigger term, it is slowly becoming a very small term. We started with 24, see, in 6th term itself it has become 0.75. Will it ever become 0? It will never, because whatever you do, you divide by 2, you will get a small number. It will be very close to 0. The limit of this is 0 because it is approaching 0, but it will never reach 0, right? But still, at the end, it is very close to 0. Very, very close to 0, right? So this kind of series is called converging series. I will come to this particular kind of series when we are doing the sum of n terms. Right? Sum of infinite terms for a diverging series, because the infinite term is itself very big, which is infinity. So it is sum of infinite terms is infinity. Whereas for a converging term, it is possible to find the sum of all the terms because the last few terms will not be even totaling to 1. Okay. So this kind of series is called converging series. So whenever it's GP, you should keep in mind what kind of sequence it is. Okay, either it can be diverging where the numbers are growing, and when the numbers are decreasing, it's converging series. Okay, this primary thought we can begin this exercise. Okay, so here we were talking about finding the general rule of a geometric sequence. So first I will give you the formula. Un for a geometric sequence is u1 r to power n minus 1. Okay, this is the general rule. U1 is the first term, U1 is first term, R is the common ratio. Okay, so let's begin with this. In the first sequence, we have U1 as 3 And what is R? 3 divided by 1 is 3, 9 divided by 3 is 3, 27 divided by 9 is also 3. So R is equal to 3. So U1 is 3, R is also 3. So we have to find general rule. So if I use this one in this formula, we will get UN equals to 3 to power n minus 1. Okay. Now can you simplify? Your knowledge of exponent should come handy now. This is 3 to power 1 into 3 to power n minus 1, which is 3 to power 1 plus n minus 1. Plus 1 and minus 1 will go 3n. So your general rule is 3 to power n for this particular sequence. Okay, understood? So you always tell you, like, keep pausing the video and write yourself. Once you write with your pen, don't try to write after seeing the whole video. It will not help. No, you should pause at every stage. Do it yourself. Now we'll do part B. Find the 10th term of this sequence. We have to find 10th term. So basically we will put here U10 is 3 to power 10. That's it. This is our 10th term. Because this is a very big number, you can leave it as exponent. In GPs, when there is a very big number, you don't have to actually calculate. You can use calculator to calculate this value. But even if you leave the answer at this stage, you will still get your full score. Okay. Let's see the next question. Here you see roots. Don't get afraid of roots. Okay. They are also very simple. The rule remains same. Here, what is the first term? U1. U1 is 3. How to find R? I told you. Divide any term, right? Any term and with this previous term. So I would, for R, I will do 3 root 2 divided by 3. What I am getting? 3 gets cancelled. R is root 2. Some kids would like to divide 6 root 2 divided by 3 root 2. That should also give same thing. 6 root 2 divided by 3 root 2. No, it is 6 root 2 divided by 6. Divided by 6. You still get root 2. Suppose you want to divide the middle two terms like this. Still R, you will get 6 only. Divided by 3 root 2. 3 2 times root 2 is root 2 times root 2. Can I write root 2 times root 2, and below 1 root 2 is there. This cancels. Once again you have root 2. So you are clear how to find R. Now you have U1 and you have R. How do you find the general rule? UN equals to U1 R to power n minus 1. So I will 3 root 2 whole to power n minus 1. Can we do any simplification to this? We leave at this point. This becomes the general rule for this question. Okay. Can we proceed to the next question? Here, this kind of questions we did in our arithmetic sequence. Same thing follows. If 4, 6 and k are in geometric sequence, that means common ratio will be same. 6 divided by 4 should be equal to k divided by 6. Correct? So what is k now? K will be 36 by 4, which is 9. Easy? 6 by 4 is equal to k by 6. So 36 divided by 4 is 9. As simple as that. Let's do for the second one. So this we did A here. Let's do B. 2 root 2 divided by k. 2 root 2 divided by k should be equal to k square divided by 2 root 2. Can I write it like this? See, this divided by this is common ratio, and this divided by this is also common ratio. I am equating them. Now cross multiply, k square and k becomes k cube. 2 root 2 times 2 root 2. 2 times 2 is 4, and 4 root 2 into root 2 is 2. 4 into 2 is 8. So k is 2 because 2 cube is 8. Easy? Let's do the third one. See, 3k upon k equals to 10k plus 7 upon 3k. Now can you solve this? Just cross multiply. 3k, 3k, 9k square equals to 10k, 17k. 10 plus 7 is that, oh, 10k, this is 10k. 10k square plus 7k. K into k, this is 9k square, k, 10k square plus 7k, right? So get this over here or get this over here. It will be k square equals to negative 7k. Cut off this k with this. So you get k equals to negative 7. Is it? So we have done A, B and C. What we are doing, we are just trying to equate the common ratio using the terms. Any term divided by its previous term gives you common ratio. And for a given sequence, common ratio is always same. So we equated the common ratio using the 3 terms. First 2 terms and the next 2 terms, right? So with this, we complete this kind of question. Let's do this one. Here, they have given different terms. U3 is 16, U4 is 48. I will do, there are many questions here. I will do A and C for you here. And just, this method will be same. You can do them on your own. And take it as a challenge, right? And even if you need support, it's already given in the mark scheme. You can check the solutions on our exercise. You will get the answers for each one. Okay, so let's begin with this. U3. Okay, U3 is U1 into R to power 3 minus 1. Do you agree with this? And this term they have given, so it becomes what? U1 R square. How much it is? They have given us 16. Look, U3 is 16. So I calculated U3 is 16. I am going to use this part. Okay, I will use this part. U3 I calculated U1 R to power 3 minus 1. So it is U1 R square. 3 minus 1 is 2. They have given it as 16. Similarly, what they have given, U4 is U1 R to power 4 minus 1, which is U1 R cube equals to 48. See, U4 they have given as 48. So U4, 48. And what is U4? U1 times R cube, right? Now you have this part. Look at this part. So if I divide this and by this, right? So what I get? U1 will cancel. R square will become just R to power 1. 1 by R, and here 16 3 times is 48. 1 by 3. Correct? So 1 by R is 1 by 3. Then what is R? R is reciprocal. So R will be equal to 3. Flip both of them, right? Now you have R, and we will input in any one of them, we will get U1, right? So I am going to put in this one. So U1 3 square equals to 16. Correct? I am putting in this. So I am getting U1 as 16 upon 9. So this is my U1. Now I have U1, I have R. Can I write the general term? Use the formula. What is the formula? UN equals to U1 R to power n minus 1. So U1 you already have 16 over 9, and R is 3. 3 to power n minus 1. This is your answer for A. Okay. So I'll move this side. Copy. Write yourself. Do it yourself once. Okay. So once you do, you will get these kind of questions. Now I'll do the C part. B is similar. You can practice, because B I see a fraction, so I want to help you. Okay. Let's do this. U3 is 3. So this time I am going to write U3 as U1 R square straight away. I am not writing n minus 1 because 3 minus 1 is 2. We know it is U1 R square is 3. And because I have given U3 is 3, I have written 3. Then U7 is U1 R to power 6 is 3 upon 4. Okay, clear? So now divide this by this. So u1 cancels. So it is 1 by, this square will go and can make it 4. 1 by r to power 4 is 3 upon 3 by 4. This 4 goes, cancel this 3 here, 4 goes here. So 1 by r to power 4 is 4. Therefore, r to power 4 is 1 by 4, reciprocal of both of them. Okay. Now, what is r? 4th root of 4, which is 1 by root 2. Root 2 to power 4 becomes 4. Root 2 into root 2 is 2. Another 2, 2 and 2 become 4. See? Clear? So now you have r. We'll input r here in this first equation. u1 1 by root 2 whole square is 3, right? So u1 1 by root 2 whole square is 1 by 2 equals to 3. u1 equals to 6. Now you have u1, you have r. u1 and r are there in your hands. Straight away write the general formula. How will you write? un equals to u1 r to power n minus 1. So un is 6 1 by root 2 whole to power n minus 1. That's your answer for C. Okay. I hope you understood this geometric sequence models of questions where we were finding the general rule of geometric sequence. Okay. With this, we come to end of this video. Thank you. Keep practicing.